Okay, good afternoon. Today we are dealing with another question, section 1.4.3, arithmetic progression. Very interesting question though. Let me put the page here. Yes, it should be this one. I think the question is short enough. I'll read again. An arithmetic progression is a sequence of the form a plus b, a plus 2b, a plus nb, where n is equal to 0, 1, 2, 3. So basically, it's a very common sequence you might see every day. For example, 1, 2, 3, 4, 5, 6, or the 2, 4, 6, 8, 10. In the later example, the a is 2 and b is 2 also. For this problem, a is a non-negative integer, so you are considering basically from 0 to infinity, the positive infinity. And b is a positive integer, so b is never going to be 0. So what happens b is going to be 0 is the sequence will be only contain a constant. It's a to infinity. We're not considering this because we have a finite sequence or finite set later. Write a program that finds all arithmetic progressions of length n in the set S of bi-squares. The set of bi-square is defined as the set of all integers of the form p squared plus q squared. What does that mean? Let me change to my notes. Yes. Okay, if you have m equals 3, which is given by the question, so your p is going to be 0 to 3. It will be at least 0 and up to m, and q is also 0, 1, 2, 3. So basically, you can construct a sequence like this. It's unsorted. If you sort it, it will be like this. This is a set S, so-called set S. And then, okay, we can put, and then you need to find a arithmetic progression sequence inside. For example, 1, 5, 9. Okay, I have a example here, 2, 5, 8, or 1, 5, 9, or 1, 5, 9, 13. This is an example sequence. If n is equal to 4, you need to find a sequence with that length in the S. And if n is 3, you need to find the length with 3 in the sequence. Okay, let me change to the question again. Yes. Okay. The important thing here is the time limit is 5 seconds. So it's trying to tell you the searching space is kind of large, or it's also trying to tell you don't really have to worry about the time of complete search. Maybe they're trying to say this. Here is m. N is from 3 to 25, and m is from 1 to 250. And you see PQ is at least 0 and up to m. So we need to firstly calculate the limit, the data limit of this question, at least on my notes. Okay, m is 0 to 250, so we consider the largest case. P is going to equal to 250, and Q is also going to equal to 250. So obviously, the largest will be the twice of 250 squared, which is 125,000. So our number our numbers are lying between 0 and 125,000. But we have only 31,375 numbers. That came from, okay, we consider as a combination of P and Q. P and Q can both equal 0 and 0, 0 and 1, or 1 and 0. But you see, if P is equal to 0 and Q equals 1, or P equals 1 and Q equals 0, they are going to give the same result. So in this case, we don't really have to compute P equals 1 and Q equals 0 again. So in reality, it's going to control by this equation, 1 plus m times m divided by 2. So you have only 31,000 plus numbers. All right. And then we need to find out a sequence, the numbers of sequence maybe have more than one. For example, n equals 3 have more than one sequence can validate this question. But there are no more than 10,000 sequence. Let me come back to the question again. Boy. Question, yes. All right, he will give you two numbers, 5 and 7, and then here's sample output. Your sample output are the A and B, A equals 1, B equals 4, A and B, and then you need to firstly sort by B. That means you can 4, 4, 8, 8, 12, 20, 24, and then in each subsection you need to sort by A. So this is a little bit tricky part in the outputs. Okay, let's see how to do this question, how to decode this question. Firstly, we know we have 31, so obviously you search if one number is in the set because it's too large. Because if you want to identify it, we need time, and we need to identify n numbers, we need to have O(n) squared. So in this case, but as we can saw, here is only 125,000. The number is up to that. So if we give a Boolean array to record down a number using the hash, we don't really facing any memory issues. So here I define a Boolean array A. The A's length will be 125,000, and the Boolean array, the index is a number, and if the index is true, and then it means the number is in the set. Otherwise, it's not in the set. So in this case, if we want to identify if a number is in the set or not, we can use only O(1) to identify. That means you can call index. If it's true, it's inside. If it's not, it's outside. And then we have a B. A B is an integer array to record all the numbers in order. But you can see if you compute this manually, you are not going to give you a sorted array. So it's basically initially your calculation will be like this. It's not unsorted. It's not sort in order. But if you have this Boolean array, and happily, because you know the m, so you know the limit, so you don't have to scan through the whole array, but you start from the first 0 to the end to the max number, and then when you find the index is true, then you add in the B. So in this case, after you scan through in the array A, you can get all the numbers in order. And here I have another array means difference. The difference means record the difference between the numbers. This difference only maintain the difference between two numbers who are besides to each other. For example, B1 and B2, B2 and B3, B3 and B4. And finally, I have a vector because I don't know how many sequences I'm going to have. Of course, the question said there is 10,000, but I don't know exactly what the number. And actually, the vector can give you another advantage, which is on the output. So I use this data structure to record down all the value sequence. Here's an example of the B and FF. The B is basically all the number you can have, all the by square all the bi squared numbers, and the DIFF is recording down the difference between two numbers. For example, this is from B1 and B0. This one is from B2 and B3. B2 and B1. This from B3 and B2, and following down. Why we have this structure is because the question is telling us the output sequence will be we order by B first. So it's kind of leading us to search B first. But as we know, the B has so many possibilities. Okay, for example, here is 0 and here is 18. So you have 18 possibilities. But if you are only going to search through A, it's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. So actually is searching A will save your time. Searching through A will save your time. And when we identify A, we need to identify B then. So there is a convenience way of using DIFF array to identify B. For example, if we assume the next element in the sequence is 2, for example, 1 and 2, and then we know that B is 1. It's 1 here. And if we think the next element is 4, and then we don't have to calculate 4 minus 1 again. We just need to add up 1 and 2. Why we do this? Maybe this makes no sense to you because I can always identify where is the next number. But in this case, we are saving the calculations. We construct the memory. We use the memory a lot to save the calculation because this question requires a lot of computation, and as indicated, it's giving you 5 seconds. So in this case, I usually will define a lot of the structures which can make my life easier. All right. Then when we identify A and B, for example, this is A. For example, A is 1 and B is 4. Let's say B is 4. So we know the next element is 5, and next element is 9, and next element is 13. Okay, we have a control is n. The control is n. So it's very easily we can write a check. We can write a function named the check, and the check is because you already have A and B, so you can have A. You know how to searching through A plus 2B, searching through A plus 3B, and all you need to do to scan if they are valid is A if okay, I need to use n and m to represent because I use A to represent array already. N plus m, n plus 2m, n plus 3m. All you need to do is to check if A n plus some, for example, j plus m, j times m is true or not. Then you can do. And another thing is about the boundary. The boundary is, for example, you have 0, you have 18. Okay, so your difference is 18. Your difference is 18, but the looping will loop through 1 to n. So after he found the next one, 18, he will try to find the next one, 36. But 36 is not in the array. So there is a potential problem is out of bound of array. We need to consider that also. All right, and then this is how we check, efficiently check. Then we turn to the program, see how to implement. You sample all these things, you can get a program like this. Okay, firstly, I see in n and m as defined in the question, and then I try to construct the array A. The array A is basically I times I and j times j. As you see here, I'm not starting from 0 again. I'm starting from I. So when I is 0, he can say 0 square plus 1 square, 0 plus square plus 1 square, 0 square plus to m square. And then when I is 1, he don't have to calculate the 1 square plus 0 square again because it's already calculated. So we start from I, not m. In fact, if you try to print it out, it's like a triangle. And then we know the maximal number inside this set is going to be twice of m squared. Okay, so you are going to scan over there. And then here we have this constructor, have this program to figure out what is B. All right, because from this block, even though we have all the numbers, but we don't know how many numbers are there. But in this one, we record down all the numbers in order, and also will give you how many numbers are there. And then it's very easily we have the difference. The difference is bi minus 1. This is the one we use to construct our b, or we construct our the small b. Small b we mentioned in the question. In this place, I call it small m. Okay, this variable largest DFF is to record down the largest DFF I can find in the value sequence. Remember, it's a value sequence. So I start to find a value sequence, then I record down if they are if the difference is larger than previous or not. This is related to our output scheme. Okay, so here this block is searching. This block is searching. It's complete search. The search is from 0 to len minus n, because we know the last possible value sequence will not going to be the last number, but be the lens minus n numbers. Because if it is the last value sequence, he will include all the numbers behind him. If we start search by the point he start the point after this number, it will not giving you any sequence with n lengths. So here we have, okay, here's the question small a. I represent small n here. Small n is equal to bi. This is a. And m, I start by 0. And here, this one will scan through all the possibility of small m. All the possibilities. By first, he recognized his second bi plus 1 as the second number, and search through. If we check search through, and in the next time, he will plus another difference. So he will try to scan if bi plus 2 is the second element in my sequence. So this one scans through all the sequence. And the check nm as I described, he will scan through all the possibilities. If it's returned to true, then I encode it to the sequence, S. And of course, if m is larger than largest difference, the larger difference equals to m. Here's the searching part, and then it's done. So the question said if you cannot find any sequence, then you output none. Here is none. If x equals 0, if it's not, you use this to output. This is a tricky part. The tricky part is we search the sequence in A's order, means the small n's order. So if you straight away output, you're going to order by small n. But we need to actually scan through small n. So here is the trick. We don't know what is the largest difference, but we know it definitely contains in 1 to largest DIFF because the small m cannot be 0 as defined by question. So and then we scan through this vector. If we found, by the way, N2 is recording the difference, which is small m. If we found the difference, then we straight away print out. And then we erase this element. When we erase this element, because you see the for loop is calling s.size, the s.size will also be smaller. So you are actually dealing with a vector which is smaller and smaller and smaller as the n will be 0. So your printing will be faster and faster. And of course, when you erase your counter here will also need to be modified to the previous, and then basically you can do it. You finish all the questions. The critical part of this is sometimes people will found the 5 seconds is not enough. It's because they didn't use the searching strategy of the Boolean. Usually because of this case, because the searching through all the numbers will cost a lot of time. Okay, let's try. But this is complete search, so the result is not really good. Let me try to submit, and you can see the results over here. Send it in. You see, at the last case, it cost me, the longest cost me 3.208. But if I change to another searching strategy, it's not going to work like this way. It's definitely not. Okay, I think this is about this question. I think we can end here. Thank you.